Our current classical communication systems that we use every day essentially rely on maximizing the information capacity of light. My research deals with maximizing the information capacity of quantum light, essentially single photons, single particles of light. And the main application of that is to have quantum communication systems in the future that allow us to transport data securely, process information securely at the rates that we need, that society needs today. I'm very interested in commercializing some of the work that we're doing in the process of trying to apply it more directly.
We are really at the interface of the technology required to detect single photons and then the data processing that's required to turn that data into real applications. Our applications range from microscopy through to foundations of quantum mechanics, and also things like long-range LiDAR, where you're able to detect the depth of something by using light that goes out to the object and bounces back.
So a lot of what we do is sort of at the fundamental level. We're trying to really engineer how particles interact, so you can get new types of sort of exotic phenomena, different types of magnetism, superconductivity, exotic optical states, and these are what we're trying to investigate. But what drives that are applications that we expect to occur in the future. So for instance, we work in a new quantum technology hub based on quantum networking, where our goal is to provide really the best single photons, and that has an industry interface. But to achieve that, we need to make new devices really, really well. And we actually have a spin-out company that we're starting, sort of fabricating very clean and reproducible quantum devices.
For example, we're trying to develop these quantum devices in collaboration with the semiconductor industry, or we're also trying to deploy them into materials that could potentially have an impact, for example, for magnetic memories, or even to biomedical applications.
Here we're working on additive manufacturing of metals using our open architecture rigs to understand the very fundamental physics behind this 3D printing process. It is a new way to manufacture things made out of metal. There is a lot of fundamental knowledge that needs to go into these processes before they can become much more user-friendly and much cheaper and much better in making parts, and this is where we come in.
Working with industry is always very helpful in terms of understanding what is the problem and what is the real-world challenges to work on. So that way we can improve the process and find out what it needs to be done in fundamental and the research process.
There's a whole microclimate that develops when things start melting. Because of the energy of the laser, there's also evaporation of the material. And so to characterize all of these interactions at their most fundamental length scales and time scales is where the real value of what we do comes in.
Essentially what we have here is enabling technology. We manufacture things, and everybody around here is wanting to make something that hasn't been made before as part of the research question. So we get involved with a whole variety of different research groups trying to provide solutions to some of their technical manufacturing challenges. So a lot of the research that we do tends to be focused on industrial application, and a lot of the ideas actually come from industry, where there's a requirement to either change or improve a manufacturing process, or a need to manufacture something completely new. So we look at the methods that you might use to do that using the high power lasers and come up with potential solutions.
We're really developing new light sources which enable us to do completely new science, new physics and new investigations of matter inside the laboratory. But then there are many aspects that are also related to industry and to healthcare technology. So for example, I have a very significant collaboration with ASML, which is the world's leading semiconductor lithography company. So they make the machines that make the microchips that end up in everyone's iPhone and everyone's computer. And they're interested in all sorts of new light sources. And so one of the main theme of my research is developing new types of light source. And so we have a very strong collaboration about pushing the frontiers of light source technology and how it can be used for different applications. It's a fantastic environment in order to really boost the sort of research that we can do.